So on the front here, we had discussed in class basically the purpose behind understanding margin of error and confidence intervals by looking at an actual dispatch poll from the last presidential election and just kind of looking to kind of estimate, see why statisticians do these types of things. So what you need to be able to do after today's lesson are three things. You need to be able to calculate margin of error from percentages as well as from confidence intervals. This first learning goal is the most common problem on the assessment for this unit because people don't study hard enough to remember that there are two different types of margin of error. So make sure that you know both of them. Second is that we need to be able to use margin of error to draw conclusions about given data, and we need to be able to build a confidence interval based on a given mean and standard deviation. So we kind of already previewed with the dispatch poll that we looked at, but a margin of sampling error, which we just call ME sometimes, what it does is it gives a limit on the difference between how a sample responds and how the total population would respond. Because no matter how hard we try when we're using samples rather than populations, there's going to be some leeway on our margin of error. So the first way to calculate margin of sampling error is right here. And it doesn't show up real well on my PDF, but on your paper you can see that this is a square root right here. So 2 times the square root of p times 1 minus p divided by n, where n is the sample size. So how many pieces of data do you have? P is the percent of people responding in a different way. Now, the key here is the percentage is in decimal form. So P has to be in decimal form to plug it in. It stands for a percentage, but it has to be in decimal form when you put it in to your formula. Confidence interval is an interval estimate of a population parameter. So in our case, we are estimating mu, the population mean. Now, we can use confidence intervals, and if you take a statistics course, there are many different types of confidence intervals. We are just looking at one little snippet of what confidence intervals are. Now, I said that there are two different types of margin of error. This is the percent, because it says calculate margin of error from percentages and confidence intervals. So ME for confidence intervals, ME is going to equal what we're going to call the max confidence interval value minus the minimum confidence interval value divided by 2. And this is only for when we're given actual amounts. So you're going to see what I mean when we actually look at the examples. So example 1, in a survey of 1,000 people, 37% responded yes when asked if they eat dinner as a family. What is the margin of error? Explain what that margin of error means. So this is obviously the margin of error that uses percentages because we're given information from a percentage rather than from a confidence interval. So we're going to be using this formula right here. So margin of error equals 2 times the square root of P. P is the percent in decimal form. So 37% as a decimal is 0.37 times 1 minus 0.37 divided by N. N is the sample size, so it says surveyed 1,000 people. Now, when you punch this into your calculator, please do it in steps instead of trying to punch it all in at once. Usually people who try to do it all at once make mistakes with parentheses and whatnot. So I did the 0.37 times the 1 minus 0.37 first, and that gave me 0.2331. Now remember, you don't actually have to round that. You can use your second answer button. Divide that by 1,000, then do square root of second answer, what you get from doing this, and then multiply that times 2. You should get, if you've punched this in correctly, 0.031. So, explain what the margin of error means. So, we have the margin of error as 0.31. What that means is that for the population, so not the sample, but taking our data and extrapolating to the entire population, for the population, the percent responding yes would be, and if we convert this back to a percentage, that's 3.1%. The original was 37, so we do 37 plus or minus 3.1%. So the percent responding yes would be between, so 37 minus 3.1%, which would be 33.98%, and if we do 37 plus 3.1%, 40.1%. So when you get 0.31, that means 3.1%. The original answer was 37%. So again, this is our margin of error. We're saying within 3.1% of that on either side. So the low, we subtract it, and the high, we add it. So we would expect the percentage responding yes to be between 33.98% and 40.1%. All right, example 2. In a recent poll, 25% of people surveyed said that they had smoked a cigarette in the past week. The margin of error was 3%. So here, instead of telling us how many people are surveyed, it gives us the margin of error and it gives us the original percentage. So what does the 3% indicate about the results? Well, the margin of error is 3%. That means the 25% is within 3% either way. So that means that the actual population percent would be between, so take the 25, subtract 3, so that's 22%, and add the 3, which is 28%. Actual population percentage is between 22% and 28%. Now it asks how many people were surveyed. If we know the margin of error and we know our original percent, we can calculate that because we can use this same formula, except now we're looking for N. We know ME. So use a different color to separate it here. The margin of error is 3%, which is 0.03. So I put that on the left side, equals 2 times the square root of 0.25, because it was 25%, times 1 minus 0.25, which if you know that that's 0.75, you can certainly put that instead of the 1 minus 0.25 over N. So back to our order of operations. Can you solve an equation? So if I want to get N by itself, the first thing I need to do is get rid of this 2. So divide both sides by 2 first. That's going to give me 0.015 equals, and then I went ahead and multiplied these out, so 0.1875 over n. So now I need to get rid of the square root, so that means I should be squaring both sides. So that gives me 0.000225 equals 0.1875 over n. Now, we have solved, especially in trig, lots of equations where we had the variable on the bottom. Remember that when you have that, you can do this little switcheroo thing where n is going to equal, change back to my blue, n equals 0.1875 divided by, and again, you can use your second answer button here. You don't have to press that all in every time. So divide those out, and you should get n to be approximately 833. So they surveyed about 833 people. So notice that we've done two different things. We have calculated margin of error from percentages, so we did this. We used margin of error to draw conclusions. The conclusions included how many people were surveyed and what the actual population response would be. So now we have two little pieces left. We need to be able to build a confidence interval, and we need to be able to calculate margin of error from confidence intervals. So, example 3. In a random sample of 38 8-week-old babies, the mean weight was 12.5 pounds with a standard deviation of 2.8 pounds. Create a 95% confidence interval for the population mean. Again, if you didn't read the front of this where we went through the poll, this might not make sense. So go back and read it, because we explained what it means to have a 95% confidence interval. But we are using our calculator to actually get this information. So what you are going to do is you are going to press your stat button, and you are going to scroll to the right to the tests menu. When you get to the tests menu, you are going to choose choice 7. Now again, there are a lot of different types of confidence intervals. We are using here what's called the Z interval, but there are other ones. If you take a stats course, you'll learn more about that. So we're going to choose choice 7, which is Z interval. So press enter. Then you should, once you have chosen Z interval, so you've pressed enter over Z interval, you should see a screen that looks like this, only it doesn't have the numbers in yet, because you're going to put that in. But we're not inputting data, we're putting in statistics, because the information that we are given was the mean and standard deviation. So you scroll right so that you're highlighting the stats part. So press enter if that's not already the case, so that this part is highlighted. When you do, you'll see this sigma, X bar, and C level. What those stand for: this is the standard deviation. Hopefully you know that symbol by now. So that's the standard deviation. X bar is the mean. N is the sample size. And C level is the percent of your confidence interval as a decimal. Notice I didn't put in 95, I put in 0.95. If you mess that up, it's obviously going to change your answers. So put in this information. It told us that the standard deviation was 2.8, that the mean was 12.5, and that we sampled 38 of those 8-week-old babies. So N is 38. Confidence level, again, is 0.95. So then once you've entered all that, go down to calculate and press enter. You should When you do that, you press that button, get something that looks like this. It spits back out the mean and the sample size, and it gives you the confidence interval. So the confidence interval here is 11.61 comma 13.39. So what that means is that our confidence interval is from 11.61 to 13.39 pounds. Now, interpret the meaning. It does absolutely no good if you can press this in if you don't know what this answer means. So it's important that you can write this out. This means that out of 100 samples, 95, because it was a 95% confidence interval, would include a mean between 11.61 and 13.39 pounds. Now, find the margin of error. This is the second type of margin of error. Again, it's so important that you know the difference between when you use this formula and when you use this one. Where did I put it? Right here. The confidence interval margin of error is different. So find the margin of error, max minus min divided by 2. So my max is 13.39. My min is 11.61. Divide that by 2. So this is 1.78 over 2, which is 0.89. So what does this mean? Again, very important that you know what that 0.89 means for margin of error. That means that our population mean, because this is a sample mean, should be between, so the original mean was 12.5, so it's 12.5 plus or minus the 0.89. So the first number, oops, and I said 12.5 and then I just wrote 12. 12.5 minus the 0.89, which is 11.61, and 12.5 plus your 0.89, which is indeed 13.39. Notice what happened. If you check this work with your margin of error, you should end up with the original confidence interval. So if you don't, you know that you calculated your margin of error incorrectly. So our population mean should be between 11.61 and 13.39. So within 0.89 of the 12.5. All right, that is it for today.